Hi, my name is Ralph. I'm a programmer and I'm also an artist. This is a special episode entitled All the Possibilities. Please enjoy watching. Have you ever wondered about how the present day could be given all the decisions you have made? You could have been a chef, a king, or even an inspector. Today, we're going to discuss something related with possibilities, permutation, and combination. Let's start with a fun demonstration. Time travel. Say we went back in time to when Michael Jackson was still alive. Now this time, we have a decision to make. We can go get his autograph or just go sightseeing. Of course, for me, I'll take an autograph which will automatically, of course, make me rich in the future. Now there's another event, MJ's fate. Let's say we have two choices. We can either save him or not. I'll leave the decision up to you. But now the question is, how many ways could we have done our time traveling journey? We have decision 1 with getting autograph or sightseeing, and decision 2 saving him or letting fate be. Let's count. 1, we can get his autograph and save him. 2, we can get his autograph and let his fate be. 3, sightseeing and then save him. 4, we can go sightseeing and let his fate be. But we could make this illustration better. So this is called a tree diagram. And this tree diagram shows the permutation of our time traveling journey. It shows us all the possible outcomes. So what if we don't want to draw a tree every single time? This is where we meet the fundamental counting principle, which states that if one event has n possible outcomes and the second independent event has n possible outcomes, then there are n times n possible outcomes. That simply means we multiply the number of choices we have and the product is the number of possible outcomes. So looking back, remember we have two choices, the first, and two choices, the second, and the product is 4. So there are 4 possible outcomes. Now, let us get a bit advanced. We have the literature club, and we're supposed to choose president, vice president, secretary, and treasurer in order by voting. How many possible outcomes can there be? Remember, we just multiply the number of choices we have. So we start with 7 and then times 6 because there is 1 already selected and 6 are left. And then times 5 because there has been a total of 2 selected. And then finally times 4 as there are 4 possible choices left. And then when we choose 4 total, we're done. What if we're voting for a larger group? Say 1,000 candidates and 100 to be chosen. We wouldn't want to write all of that down. Luckily, there is the factorial notation and works like this. So 7 factorial would then be 7 factorial is equals to 7 times 6 times 5 times 4 times 3 times 2 times 1. So if we look back to our problem, remember we have 7 students, of which 4 are to be taken. In the end, we just want to have 7 times 6 times 5 times 4, right? So how do we do this? This is called the permutation formula, and it is read n objects taken r at a time, and we go 7 objects taken 4 at a time. Okay, so this is the permutation formula. It's n factorial over the quantity n minus r factorial. The permutation of 7 objects taken 4 at a time is this, with a total of 840 ways. So next up is combination. Think about this. You're supposed to make fruit shake with 3 of these fruits. Unlike in permutation, the order by which you blend them doesn't matter. Taking apple, banana, and pineapple is the same as taking banana, apple, and pineapple. This can be represented by 6C3, read as what is the combination of 6 objects taken 3 at a time. We're supposed to only take 3 fruits. Now, this is the formula for the combination, and we can simplify it to this. And so if we solve the problem, we get this, which is a total of 20 ways.